Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on the topic of physics, that is momentum for Igcse physics and impulse velocity. In this question, we are told curling is a sport played on ice. A player slides stone A across ice towards scoring zone. The ice reduces friction so that there is negligible friction when the stone is sliding. We are told that stone A leaves the player's hand with a velocity of 2.9 meters per second. That is stone A. The mass of stone A is 17 kgs. State the formula linking momentum, mass, and the velocity. So in part A, Roman 1, we are going to say that momentum is equals to what? Momentum is equals to mass times velocity. You have to remember that the momentum is equals to mass times velocity. So in that case, with that formula now, we are going to use it to find the momentum of A. And this is Roman 2. We are going to say now momentum, of course, we have said is M times V. And that is the symbol for the formula for momentum. And then we're going to say, therefore, this is going to be the mass, and the mass is 17 kg times the speed, which is 2.9. If you work it out, 17 times 2.9, that translates to 49.3. So which is approximately 49.3 kg meters per second, which is approximately 50 kg meter per second. So that is the formula we can be able to use. And now let's look aside. Let's look into another part of this question that was asked in this particular exam. So let us look at the second part of the question that was asked here, and direction as the initial direction of stone A. The velocity of A after collision is 0.4 meters per second. So what was the initial velocity of A before collision? It was 2.9. So we're going to use the principle of conservation of momentum, that the momentum before should be equal to momentum after collision. So in that case, we are going to say, because stone A was the only one that was moving, so the momentum before is 50 plus 0 should be after collision. We are told that A moves at this speed, 0.4. So it means then it will be 17 times 0.4 plus the mass of stone B, we are told is what? 19. So the velocity at which it will move, we don't know. So we are going to say 50 is equals to 17 times 0.4. That gives us 6.8 plus 19V. Then we shall say this is 50 minus 6.8, which is equals to 19V. So 50 minus 6.8, that's going to translate to 43.2, which is 19V. Then we can divide by 19, our V is going to translate to 2.27 meter per second as the velocity at which stone B is going to move after collision. When the stones collided, they were in contact for 0.25 seconds. When the stones collided, they were in contact for when the stones collided, they were in contact for 25 milliseconds. Calculate the magnitude of the force stone A exert on stone B in this collision. So we're going to use the concept that impulse is equals to change in momentum and also we need to remember that impulse is also equal to force times time. So we need to know the change in momentum for B. Change in momentum for B, we need to know it. Then we use it to work out the force that was exerted on it. How are we going to go about that? How are we going to go about that? This is what we are going to do. We are going to say for part C, that's part B, Roman 2. So for Roman 2 of part B, we are going to say change in momentum. Momentum of ball B initially was 0 because initially it was at rest. After it was after collision with the first ball, after collision with A, it moved at this velocity. So we can work out its momentum after collision. So we can say change. We can say momentum is going to be 19 times 2.27. This is going to be what? 19 times 2.27. This is going to translate to 43.13, and this is going to be the change in momentum because initially the momentum of ball B was 0 because it was stationary. After collision, its momentum becomes this. So the change for momentum for ball B remain to be this value that we are having at this given point. So we can be able to say at this point of time that impulse is equals to Ft. Impulse is going to be equal to Ft, and since also impulse is changing momentum, we have already gotten changing momentum to be this. We're going to say this is going to be 43.13 is times the time, and our force is going to be 43.13 divided by time. Remember, we are given the time, which is equivalent to 25 milliseconds. And if you are given time in millisecond, it means to convert it to second, you need to divide by 1,000. You divide that time by 1,000, so it will be 25 divided by 1,000. This is going to translate to 0.025. So this 0.025. If we work out that force, which is 43.13 divided by 0.025, our final answer becomes 1725. 1725 as the force. 1725 Newton as the force. Because we are multiplying mass and the velocity, so this means that the SI unit for momentum is kilogram meter per second. Is a vector quantity. Those are the ideas that we really need to put in mind when we are talking about Igcse physics as far as this topic on momentum is concerned. So in that case, we need to remember the units. You need to remember the formula for momentum, and the symbol for momentum is usually P. Symbol for momentum is small p is equals to mv. So this is the formula for momentum in symbols. Now, for instance, if you are told that there is a car that is moving, this car has mass equivalent to 700 kilograms, and this car is moving at a velocity of 2 meters per second, and then you are expected to work out the momentum. It means we are going to apply the formula momentum is equals to mass times velocity, and in this case our mass is 700 times the velocity 2, and the answer becomes 1400 kilogram meter per second. This becomes the momentum of the car. Then if you are going to do also Igcse physics, the other concept that we are going to learn is what we call impulse. Impulse is a product of force and mass. Is a product of force and time. So which means that impulse is equals to force times time. That is the formula we shall be using when we are calculating the impulse. So which means when a force acts on a given object for a short period of time, we can be able to work out the impulse for that case. Now, suppose we are having a question here whereby we are told a force of 500 newtons acts on an object for 0.04 seconds. Then we are supposed to work out momentum. What is the momentum in that case? So rather, what is the impulse for that case? Impulse is going to be force times time, and in that case going to be 500 times 0.04 seconds. Then if we work this out, the two zeros will cancel with this decimal, it will move forward like that, and then we are going to have 20 Newton a second, and the unit for impulse is Newton second. Another formula that is used to work out impulse is the formula impulse is also equivalent to change in momentum. What I need to mention is that you can be given a question, and in this case here you can see we have a question whereby we are told the diagram shows two blocks at rest on a table viewed from above. A spring is attached to the block, to the large block. A small block is attached by the string to a fixed point on a table. A student pushes the two blocks together so that the spring is compressed. Then the student releases the blocks. The kinetic energy store of the small block is 0.29 joules when the block are no longer in contact. Show that the speed of the small block is about 6 meters per second. So in order to work out this question, something that we need to remember is that we are using the concept of kinetic energy. And in this case, we are going to start by saying that kinetic energy is equals to a half times mass times velocity squared. That is the formula for kinetic energy. So with this formula, what are we going to do? We already know what the mass is. And if you can look at the question that we are provided here, the mass is in grams, so we have to take that, we divide it by 1,000 so that we convert the mass to kilograms. Then we can be able also to substitute into the formula with the kinetic energy 0.29. So we can say in this question that a half times the mass 0.09 0.017, which is the mass of the small block in kilograms, times the velocity v squared, which we don't know, should be equal to 0.29, the kinetic energy that we were told in this case. So which means that we are going to substitute into the formula, or we are going to make v the subject, and making v the subject, we are going to say it will be 0.29 times 2 divided by 0.017. Then if we put this into the calculator and then find square root both sides, we are going to get our v, which is going to be equivalent to what? Let's put it in the calculator together, and this is going to be 0.29 times 2 divided by 0.017, which translates to square root of 34.11. So if we work out the square root of this number, we are going to get 5.84 meters per second, and we are going to see that this answer is approximately equals to 6 meters per second, which we were supposed to show at this given point. So second question here, we are told that using idea about momentum, show that the speed of the large block is about 1 meter per second. So we are going to say that momentum of large block should be equal to the momentum of the small block. So that is the idea of momentum that we are going to use in this question. So on that regard, remember the mass of the large block was 75 grams. So we are going to say 0.075 times the velocity of that block, which we don't know, will be equal. The mass of the small block was 0.017 times the speed, which we got as 5.84. 5.84 as the velocity of that. So if we want to find the speed v, we are going to divide by 0.75 divide by 0.075. Of course, we can see that this part and this part will cancel out, and our v is going to translate to. So if I take 0.17 times 5.84 divided by 0.075, my answer is going to be 1.3 meters per second, which is approximately 1 meter per second as shown there. The small block takes 0.11 second to reach this velocity. Remember, for part C, we're going to say initial velocity of the small block was 0 meters per second. Then the final velocity becomes 6 meters per second at that point. So we can be able to say acceleration is given by the formula final velocity minus initial velocity, and our initial velocity we know was 0 meter per second, divided by the time taken, and our time is provided. So we can be able to say that our acceleration will be 6 minus 0 divided by 0.11. If we work it out, we are going to get our answer equivalent to what? 6 minus 0 divided by 0.11, and our answer becomes 54.5 meter per second square. Now, since we are asked to work out the force exerted on the block, we are going to say, using the formula, force is equals to mass times what? Mass times acceleration. And in that case, we know the mass of the small block was 0.017 times the acceleration, which is 54.5. If we work out this, we are going to get our answer in equivalent to what? Try to use your calculator at this point of time and show me what answer you are getting there. So we have 54.5 times 0.17, 0.017, and the answer becomes 0.2965. The answer becomes 0.9265 newtons. We are talking about force, so force should be given in newtons. So whatever that we have done in this particular question is how we can be able to apply questions to do with momentum and also impulse. So let's dive in so that we can get to see what we are going to do in another type of exam question. There is a ball that is moving, and this ball hits a racket. So we are having a ball that is moving to hit a racket. Now, for instance, if we are talking about a ball that is moving at 30 meters per second, and then it hits the racket here, we need to know what is the mass of the ball. The mass of the ball, let's say it's 20 grams. So if it hits the racket, what will be the impulse? So we need to analyze a few things here. When this ball is moving, it's having initial velocity of 30 meters per second. The moment it hits this racket, its final velocity is going to become 0 meters per second because it's going to be momentarily at rest. So what you need to remember is that impulse is equal to change in momentum, right? So impulse, we have said, is change in momentum. So we can say impulse of the tennis ball hitting the racket is going to be equal to change in momentum. Now, in that case, remember, change in momentum is going to be mass times final velocity minus mass times initial velocity. Mass times final velocity is going to be giving us the final velocity, the final momentum of the ball. Mass times initial velocity is going to be giving us the initial momentum when this ball was moving towards the racket. So in that case, we are going to say, therefore, mass into V minus U is equals to the change in momentum. So this is going to be, the mass is 20 grams. So we need to divide this by 1,000. If we divide by 1,000, we are going to get the mass in kilograms. And remember to convert into the SI unit. So this is going to be 0.02. 1, 2, 3. Yeah, so meaning that if you divide in this case, you are going to get You're checking, sorry. That is 0.02 kilograms. And final velocity in this case, we said when it hits the racket is going to be 0 minus initial velocity, which was 30. So if we work it out times 30, that's going to translate to 0.6. And something that you need to remember, of course, our answer is going to be negative 0.6, negative 0.6 Newton seconds. The units for momentum, the units for impulse can either be kilogram meter per second, or it can also be given as NS. And there is also no harm having a negative here. We can just say it is 0.6 Newton second. We can also give our answer like that. And if you are new to Proflan YouTube channel, consider subscribing so that when I'm going to upload another tutorial on the same, you'll be notified. as far as this topic is concerned is about collision. So we have the first type of collision is called elastic collision, and we have number 2 in elastic collision. So when two objects collide, or when two objects hit each other, then we have two types of collision. If the two objects hit each other, then both kinetic energy and momentum are conserved. Then this is a type of collision which we call elastic collision. Here we are going to say only momentum is conserved for elastic collision. So something else that you need also to remember in this topic, as far as this topic is concerned, is the concept known as law of conservation of momentum. The law of conservation of momentum. So we are going also to mention law of conservation of momentum. We are going to talk about principle of conservation of momentum. So the principle of conservation of momentum says that momentum before collision, we can talk about total momentum before collision is equal to total momentum after collision. So total momentum before collision should be equal to total momentum after collision. Now, for instance, if we are talking about an object here, which is A, and this object A has mass equals to 2 kgs, and this object is moving at a speed of 12 meters per second, to collide with another stationary ball B of mass 10 kg that is at rest. At rest means it's stationary, it's not moving. So after collision, they combined and move together with a common velocity. If they collide and move together after collision, they move together with a common velocity. So in that case, V. So we are supposed to find our V. How can we be able to find our V? Something that we need to remind ourselves is the principle of conservation of momentum. You don't want to watch out. Is the principle of conservation of what? Momentum. So in that case, you need to say momentum before equals to momentum after. That's the concept that we are going to use in this case. So we're going to say momentum before collision is equal to momentum after collision. Now, before these two bodies collide, this one is moving and this one is not moving. So meaning we can be able to ascertain and say momentum for this one before colliding was 2 times 12 plus this one, it wasn't moving, so we shall use the mass 10 times 0, because the velocity was 0, it wasn't moving. But when they collided, they moved together with a common velocity, meaning the velocity of A will be V, and also the velocity of B will be V. So in that case, we can say the mass of A is actually 2 kg, so it will be 2v, because is the mass times the velocity for a given momentum, then plus the mass of this one is 10 kgs, so that will be times v. So in this case, we're going to get 24 plus 0 is equals to 12v. So this is going to be 24 is equals to 12v. So divide by 12, divide by 12. Our v is going to be equals to 2 meter per second. They are going to move together at a common velocity of 2 meters per second. So that is how you get to solve different questions, a given question involving collision. So if you are given another question whereby you are told that this one is moving, initially if it was moving, then we were to multiply that velocity at which it will be moving at this point, because it will be having initial velocity also with it. So depending with the kind of question that you are given, you can be able to put in, as long as you understand the concept that momentum before collision is equals to the momentum after collision, which is the law of conservation of momentum. At this given point, I would like to say that mostly students confuse between moment of force and momentum. So if you are having a challenge on how to answer a question like that, I'll be doing more tutorials regarding Igcse physics and A-level physics, so that anytime I upload a video, you'll be notified. Just take this moment to subscribe and also to leave a comment down below if you got help in this particular video. See you in the next lesson. In this question here, we are told that we have two bodies which are moving. A is moving at 10 meters per second and B is moving at 8 meters per second. The mass of A is 4 kg and the mass of B is 2 kg. After collision, A moves at 4 meters per second, B moves at V meters per second. How can you be able to work out the value of V? In this particular question, we are going to use the principle of conservation of momentum, and the principle of conservation of momentum states that momentum before collision is equal to momentum after collision. So we are going to write that and say momentum before is equal to momentum after. So in this case, you need to remember that momentum is calculated by the formula momentum is equal to mass times velocity of an object. In that case, if we want to find the momentum before collision, it will be the momentum of this object plus the momentum of this second object. And that is going to be, mass of this object will be 4 times 10 plus 2 times 8. It's going to be equal to, after collision, after they collided, this moved at 4 meters per second, but its mass was 4 kg. So that will be 4 times 4 plus, this moved at V meters per second, but its mass was 2 kg. So this is going to be 2 times V. So this becomes 40 plus 16 is equals to 16 plus 2V. Then this, if we add this, we're going to get 56 is equals to 16 plus 2V. Then if we take this on this side, to be 56 minus 16 is equals to 2V, and this is going to be 40 is equals to V. Divide by 2, divide by 2. In this case, we'll have this cancelling out, this cancels out, we're going to get 20. Then we can say our V is 20 meters per second. This object B moved at 20 meters per second after collision.